Hi everyone, welcome to another episode of the Lisp Study Group. I'm your host, Ron Batum with Atlanta Functional Programming. The last couple of weeks we've been kind of running different experiments with CFFI, the C foreign function interface, as you all know. Last week I kind of covered a couple of different routes that we're going to be spending time today continuing to cover and kind of explore. The first thing is obviously related to calling Go functions from within CFFI via the approach that I mentioned, which is essentially compiling the Go library as a shared object and loading it using CFFI as a normal C library into your Lisp image. I gave a basic example that successfully kind of illustrated the point, but we were going through a complex example, encountered a bit of an issue mainly when dealing with Go strings that I thought we'd spend time today kind of debugging, especially since I did some investigation afterwards as to seeing what the issue was related to that, and thought I'd give some update regarding that. The second thing that we covered last week was related to calling Lisp, actual common Lisp code from C, as a shared library, and I even mentioned that if you performed it this way and actually compiled your code, then there is a possibility of leveraging SBCL as a shared object library in other languages that allow you to actually load up C shared objects and then kind of use the same pattern to call your Lisp code from those languages too as well. And when we encountered that, we ended up hitting this one situation where there was a segmentation fault that was occurring when we were trying to execute our basic example of calling an add function from within a C program. So we're going to cover both of those and kind of debug some of those a little bit more in detail today and do more of a deep dive. At the same time, hopefully time permitting, I can actually finally show you the SBCL-Librarian library that kind of culminates all of this research that we're kind of doing and playing around with. The reason why, just for folks coming in and wondering why I don't just jump straight to SBCL-Librarian is a couple of things. One is SBCL-Librarian only currently covers Python and C, which might cover the majority of cases of how people are leveraging C libraries, but still, especially given that certain languages are becoming more popular, such as Rust, and even established languages like Go allow you to hook into C shared objects the same way. It would, be useful for us to know how and where and why we would actually hook into our Lisp code using SBCL as a shared library, DLL, into those languages too, so that way we could get the same benefits that we would if we were, just using Lisp and C as is. All right. As usual, these discussions are very informal, so for those of you who are on the Jitsi chat, as well as many of our YouTube viewers, if you have particular questions regarding anything related to the material that we're covering, please feel free to throw your message into the chat during today's stream, and I will answer them accordingly. Additionally, as I will always want to mention through all of these, if you like our videos, please do subscribe to the Atlanta Functional Programming YouTube channel, just so that you could get notifications on latest content, especially as more of these shorter and longer videos tend to be posted. One more announcement that I want to kind of mention to all of those who are here in YouTube land, as well as many of you who are local to the Atlanta area. Atlanta Functional Programming is looking for talks and for topics to discuss outside of just Common Lisp. Of course, Common Lisp is our weekly discussion topic that we tend to have during these streams. But in addition, Atlanta Functional Programming does try to encourage folks to talk about functional programming and its techniques and best practices in a more unified forum that is language agnostic, just because a lot of these concepts have now been more or less accepted by the larger programming community and software engineering community. So if there is a topic that you're interested in, feel free to reach out to me. I am Bugram on Discord in the Lisp Discord server, as well as I am Bugram in IRC in Libera, as well as functionalprogramming.slack. So if you are in any of those venues and you have a topic, feel free to DM me and I will get you scheduled. Also, another announcement for folks in the Atlanta area, Atlanta Functional Programming is in need of a new in-person home for in-person meetups. For folks who have ideas on potential locations, by all means reach out to me and I will, or my co-organizer Judd Taylor, and we'll try to set something up so that we can start having in-person meetups again. In the meantime, we will end up we'll be continuing our online discussions and topics. Okay. So last time we kind of covered this kind of basic example of running a Go program. And you could see that the pattern that we were kind of using is much the same way of the normal typical pattern that you would encounter when you are loading any other C library. In fact, we have kind of a basic example to show the differences between what you would do in a C case. So we have a shared object called myMath that myMath is nothing more than a simple math C library that I wrote that has nothing more than a function called add. And just to show for folks who haven't been here, it was basically nothing more than wrong one. Where was it? It was in Go examples. One second. It was myMath build. Oh. myMath.c is been. Oh, it's been converted. That's right, because I just moved it out. Just check something here. Not a big deal. We could just quickly do this. And so we had originally, and unfortunately, it looks like I kind of blew it away when I was trying to consolidate everything in a single example directory. We had kind of an example like this. We had, let's say, we'll call this utils h. Obviously, we're going to have that, and then we have kind of a function that takes in two integers a and b. Okay. And then obviously with we created util.c file that will just nothing more than define our utility function. Okay, nothing major here. And obviously we need to go in and change our build. Let me just go ahead and change this just so that we're not trampling over anything. And obviously, so to build this library, what you had to do is just basically go in and for folks who are not used to seeing CMake, you just had to go in and go into the build directory, rebuild. Oh, right. One second. I forgot that I don't have CMake installed on this. Well, I do have it. It's just that for some reason Emacs doesn't seem to like it. Do that. Okay. And then we do a make. Okay, we got our library. Okay. And this function is nothing more than something that can easily be shown as just a simple lib mymath.so grep dash t, and you can see our add function got added into the DLL. Okay, all good. So how do we actually load this is the question, right? We end up loading it just simply looking at the search path here. We then add our, oops, I forgot that I did not load, sorry, our that, okay, and we load it. You can see that it gets loaded. We can then run it, and you can see in our function we have this compile that would simply spit out loading up our actual library symbol, and then subsequently it will then load mymath.add. Okay, now obviously this is nothing new, and last week we also covered the Go example of this with simple functions, which was, if you recall, nothing more than Go example, a function that simply had two utility functions. The first one is nothing more than we have something called printInt that will go ahead and print the integer, and something called add that will go ahead and add two numbers just like we had before. Difference being, of course, is as I mentioned last week, in order for you to actually compile this, you're going to have to use a tool that Go provides you called build mode inside the Go build tool. But on top of that, when you are building it, you're going to have to actually add annotations, particularly to export the symbols into your shared object. It will end up requiring you to use the C namespace here as indicated, and then you have to add a comment with each exported symbol and specify ultimately what the symbol name is going to be when it goes in generates the shared object. What I didn't cover last week, and I thought I would first cover today, is what exactly other than the shared object that's getting generated by the Go build tool, what exactly does the Go build tool also do? And this is important because of the fact that when we are talking about things like, say, Go style strings, okay, strings representations is very different from language to language, and so you need to understand that to correctly handle strings in that particular language of choice, and even move strings in and out of that language to other languages, you're going to have to respect its object representation in that language and make sure that you appropriately serialize and deserialize, or if you like calling it marshalling, you marshal the object across the language barrier so that it appropriately gets managed by the owner of the memory of that string object. Okay, because in most other languages, strings are represented as proper objects with three members, one being the contiguous block of memory representing the string, the capacity of the string, and the size of the string, just so that, if you're dealing with Unicode characters versus ASCII characters, it accounts for that in the memory footprint of the actual string object itself. So I thought I would start with that by first bringing out our shell again, and in here I thought I would show you the two objects that get generated here by first rebuilding this thing. Okay, so let me just do a quick go clean. I think it will work. Oh, right, because the fact that it is build mode, I'm going to have to remove these two. So I'm just going to tell you which things get generated here. The first thing that gets generated is this header file and the shared object file. I thought, it would be first important to kind of illustrate that this gets generated, but of course, I didn't actually set that up, so give me just 1 second here. Okay. And, okay. go ahead and do this. We do go build build mode -c-shared -object foo.so maybe foo.go. You'll see that when we're done with the project and we're done building, you end up getting these two object files like I mentioned, okay? The first thing that I kind of showed you is already available. You can see that if we do this and we do -e t add and -e t printend, we get the appropriate exported symbols like we did before. All's good. But what is this header file holding here? Well, this header file is important, well, not so much now for our basic primitive types, but it will become important when we start talking about strings. This header file kind of holds the type declarations and the specific exported Go types, it's appropriate marshalling metrics in some cases, for being able to communicate back and forth from Go. Okay, and so let's take a look at this guy, foo.h, just to kind of give you an idea. So you can see immediately that there are some preprocessor definitions that are used by Go. Obviously, the standard so that you have the one definition rule for your C. You have your preprocessor definitions of if not defined, define. And then we start going into the particulars for different objects that we're using internally that end up requiring some sort of exported object that's in the C equivalent. So this way you can do again appropriate just standard marshalling, demarshalling, and more importantly, when you're writing code that calls out to the Go library equivalent, in the cases when it's dealing with objects that need to be serialized, if you're not aliasing them correctly, you'll then get appropriately compile time errors. Okay, a lot of this shouldn't be unfamiliar to the audience that is watching this, but just a quick note: type defs is still being used here instead of using for folks who are looking at modern C++ or even modern C. And additionally, you have type defs for your basic complex types as well. And these are the integers and primitives types. You don't necessarily need to worry because of the fact that behind the scenes, since they're the same representation, the implicit casts tend to work, but they are available to you so that you can be more explicit when you are declaring those variables inside your code, inside C. The main stuff that we'd want to look for is not so much slices for now, but the examples is the Go string that we were looking at, and whether or not we actually need this. This is the actual example that we were doing in a separate example, but I thought I'd at least show this here, that it's still always part of the header file, regardless of whether or not you are actually declaring a function that requires C. So the Go build tool does not necessarily optimize and give you just the subset of primitive types you're actually using as part of your library. It does give you everything. All right. This will be useful for folks who do who not only write common Lisp bindings, but if you so choose to decide to leverage Go in other projects. So I thought I'd at least mention that this header file is always generated. The one thing that I will say that this shows us is if we go to our actual example, which is the my math example, this becomes important to us when we start talking about the actual binding that we want to convert with when we're dealing with strings. So let's recall let's go back. Oh, I do have it available. Okay, good. So let's go back to our original code here. Oh, before I do that, let me just do one more thing, which is let me examples.lisp. Oh, no. I'll go my math examples.lisp. I want to kind of show you on this printed that I created. Let's see this here. Oh, I didn't. That's right. I forgot to do this. MCR. There we go. And we can see go add works the way we want. And we saw that printend may not actually work the way we expect it to. You may expect that printend is going to actually go in and print out the standard out, but standard out is being redirected internally. So the standard out that's being used by the Go library doesn't actually hook into the Lisp runtime. I'm not entirely sure why that is. There might be a way of encountering that, but for now, the one thing to be aware of is if you wanted to print this out to standard out, you're going to have to do what we're about to show you here, which is create a function that will log to by returning the actual log string itself. Okay. So let's go back to doing that. Let's do a quick code review here. Recall last week we defined this module, myMath, which is a Go program. It contains a new type called season. Season ends up being used to ultimately give us a switch statement that's being used later on. We use season to define an enumeration to define seasons, and recall in Go there isn't really a such thing as enumerations per se, in that they're not sum types, they're just constants that tend to be mapped to a particular type. Alright, so you can see that with the constant block there with the seasons being defined. And then we have our actual print tool that actually goes ahead and switches and returns the appropriate string based on what season was actually passed in. Alright. All this is kind of very nice and kind of useful for us to be aware of. And but hold on, let me just do this. Okay. Let's go back to eShell here and here. There we go. And let's go ahead and build this C shared mymath.so and let me do lib mymath.so and let's do mymath.go. Okay. So again, as I pointed out before, this generates two files, libmymath.h and libmymath.so. When we go and look at libmymath.h, we can see that this is what it's actually getting generated before with all the primitive types. And you can also see now there's some additional checking for integers being passed in, and this is being used later on when we're actually defining our functions. Here you can see that goString and getSeason has string and goInt are appropriately being used as part of the declarations to the external functions. All this is kind of shouldn't be news to the folks who were with us last week. The one thing that you recall that is when we attempted to actually load this and try to use getSeason has string, it ended up giving us a bunch of garbage, right? And this is what we're kind of gonna begin our exploration with after I kind of revisit that particular thing. Okay, so here let me go ahead and do lib. There we go, and let me go ahead and for cleanliness, I didn't do this last time. Let me go ahead and add our compile time guard to make sure that anytime we load this particular script, we can have let me make sure I even go even further. We're going to just do a find package here. and the symbol is going to be CFFI. We're going to do a quick load CFFI just to make sure that it's always available to us, all right? And that should be fine. Good. So we now load the library. We defined our C things, and here is where we're going to begin our discussion. If you recall, we defined our getSeasonHasString function that takes in a season and returns the actual string that's being returned as such. But when we tried to run this, and we tried to use, say, winter, we ended up getting everything from winter, spring, summer, fall, as well as garbage being passed in from the garbage collector, okay? And part of this is you could see if you pass in the actual integer, you ended up getting the same kind of garbage collection. So we need to actually go and wrap this guy behind some information, okay? A couple of things. One, why is it that when we use defcenum, it didn't actually allow us to use the key bindings that it defined? Well, this is something that we're going to hopefully discuss today, but to make it pretty simple, you can see that here, even though we're making a foreign enum here, for some reason it's not mapping it to the integer type that Go specifically is leveraging. So these are C enumerations, they're not Go enumerations, okay? So we're going to have to essentially do something slightly different if we're going to try and say you're going to create Go bindings, okay? I thought I'd at least mention this here, just so that in case folks are wondering why this isn't doing what it's expected to do. This is because the signature of print season, as defined by the symbol in the shared object, isn't necessarily mapping it to the equivalent. It is just grabbing, you know, it's not converting it into an appropriate integer. Instead, it's doing something else, which is kind of rather unfortunate. Anyway. So let's go ahead and figure out how to fix this particular thing, at least so that we can use Go integers, and then we can clean this up to actually go and deal with seasons appropriately. So this goes back to the definition of this guy. What is a Go string that's being returned? Okay, and how does that map to getSeasonHasString? Well, we could get some indication on how this works by looking at the generated libmymath.h. Okay. And specifically, we need to go and look at how they define a string and see if we can actually map it accordingly to their string type, okay? So what does this look like? Well, it looks like this. It is a pointer to a character with the appropriate pointer diff t. Pointer diff t is basically the size of the actual string, okay? And that type is usually a size of an integer. So we're going to go ahead and convert this to actually look the same way. And let's see if we can actually map this the way it would be appropriately mapped with C objects, all right? Give me just 1 second here. Just looking at one thing. Right, so we're going to have to kind of map this to the same issue. So the approach that I'm going to propose that we do is somewhat similar to something that I've seen in Medium articles that talk about calling Go from other languages, which is we have to figure out how to map these two fields exactly. So I'm just going to go ahead and name this P and N to kind of map what the Go string underlying type is defined as. Okay, I'm going to see if this actually appropriately gets generated to Go string. So let's see what happens. We see compile from error reason unknown CFFI type Go string. So this is defined as a for instruction type. Parse method Go string. Parse deprecate Go string struct. Okay, so this is being returned as a Go string. How do we end up leveraging it again? It is alright, this one is actually complaining about the fact that this is not getting constructed, isn't it? Let me see if I could do this as a symbol. Oh, right. That's right. Look at the error here. I don't know, let's see if I type. But I just defined the foreign type. Let's see. This def struct becomes a foreign struct type. Foreign struct definition. It contains it, and then it has a parse method. String. Oh, okay, got it. So this should be actually labeled this. Unknown. Wait a second. I'll label this as a Go string. What is this getting generated from? Okay. So the issue is related to the fact that even though we defined a Go type, let me do this. I want to see if I could do pointer. So it says that we deal with strings correctly. So when we use def struct, this should actually have created a function parse deprecated struct type and use a goString T class. Oh. Okay, so it looks like we're going to have to write a foreign type translator here to translate to and from the actual goString type, because we can't just necessarily use string as is, because this is an object that they defined, and there has to be some additional translation methods to actually go and convert. Alright, so we're going to learn something new about CFFI, which is how do we define an actual type that that's an object that essentially wraps itself around an object that the shared library that we're loading into our Lisp image uses. And what we need to provide marshalling code to actually be able to go back and forth from this type. Okay, so this is a little bit new for me, so let's go through this step by step. I have to go and remind myself how this works, because I've only read about it, I've never actually done it. Let's see. This should have actually worked. I'm a little surprised that this did not work as I expected to. we end up using So we may need to actually define a parse method here, which is why this isn't working the way we expect it to. What I mean is for foreign structures, it might be the case that we need to add like a function translate from foreign, translate with foreign. So let's see how this might work. Here. Oh, right. I'm changing my layout just so that I can get a better picture of, and show you guys a better picture of like what the error message is. Okay, so it looks like I'm missing one more library here. loaded that. Actually, you know what? I'm going to start my Lisp just to be on the safe side. Okay. And it looks like my presentation mode stuff is working. Alright, let's load this again. Okay. Load our basic math library. Load this. This should be string. Load that. And what happens here? Oh! Okay, it looks like it worked. Let's see if print season works the way we expected to. No, it did not, because it's not wrapping it inside of a C object. Okay, so this guy is generating a bunch of stuff. Okay, got it. So, let's see. So, didn't fix the actual problem. It generated us a object and a return a pointer to it. Okay, give me a second. One way of dealing with this is, let's see if we could do what I was suggesting, which is define a method called translate CFFI translate from foreign. UTR is going to be of type go string. And what this is going to do is we're just going to grab the information and see what happens. We're not going to actually construct a new string. We could certainly do so. It's going to print out and let it get thrown out into memory. So let's see, format T, value A, and I think it's called you want to actually do let's see what happens here. This is see if I can do it this way. Yeah. So doing type go string, as it says here. Let's see if this CFFI with foreign slots. PN, and let's do PTR, and the type is type GoString, format T value, and let's even print out its size. Okay, let's see if this works. No class. Oh, so this is probably using the string class that was defined. PTR string T class. Okay, required was task with defined with specializers. Oh, okay. Let's see what the overrides of this is. Value is PTR. Type is going to be T class. Okay. There we go. Oh, wait. What did it complain about? Slot value here, type GoString, and 2 warnings. What is it complaining about? Oh, here we go. Warning. Error compiler. Unknown CFFI. Oh. Right. Okay. Let's do that. Almost there. Unknown CFFI type. Okay, so I have to specify here, not GoString T class, but type struct GoString. There we go. Okay, so let's clear the REPL here. And let's see what happens when I run print season 2. Okay, so we're getting closer to what we want. Here, instead of actually getting the list, we're now actually getting the override the way we were expecting it to. Thing is it's still giving us this weird string with the full stack trace that we're providing. Okay, so let's see how we can resolve this issue. In this particular case, I think the reason is another thing that I should mention, which is in CFFI, this string that you see here is a ASCII string. It is not a UTF-8 encoded string. I mean, I think SBCL internally still uses UTF-8, but as far as I know, I think for purposes of interoperability with C, it maintains ASCII-ness when it does colon string instead of pointer to char star. Now, folks who are more experts in this particular subject who are watching the stream, by all means, feel free to put comments in the YouTube discussion I will correct myself, but I'm pretty sure, based on my understanding of how the manual works, that is the correct case. So, how are we going to handle this is the important question. So there are ways of doing this, and I've seen part of this in the CFFI manual. I just got to go now remind myself what is the actual flag. So give me a second. String types. I'm actually curious if, let me convert this just for my own sake. Let's convert this guy, instead of being of type goString T class, let's see if I could do it like that. Because this should work, but, that's right, it's not a parameter specializer. I have to use the goString string class in order for me to appropriately do this. I mean, it's working, the fact that we're doing it, but you know, it's still let's see what we need to do to appropriately. Let me try also one more thing, just for my own sake. There is nothing there. 3 is fall, so it gives you. Oops, hold on. I have to clear this. Do this again. There we go. Yeah, it's fall. Got it. So one way of converting this to the way we expect it to is actually creating a actual appropriate structure that we'll call CFFI, we do def struct, and we call Lisp, goal Lisp string. Although, and I hate when this happens. My apologies, I have to still fix this. One more issue with my Emacs setup, where it has a tendency of still doing autocomplete and think it's smarter than what I do. Okay, and we're going to go ahead and do let's just call this value and size. Oops. Value size. So this is just a basic Lisp string structure that maps exactly to what the goString structure is. All right. I didn't want to use P and N just because of the fact that P usually is a suffix for predicates, as you know, in a lot of Lisp functions. So by using it, it could be, tends to be a little bit. It'll be a little strange. Although in this particular case it wouldn't have mattered, just because it will end up saying go Lisp string P. It'll generate the appropriate accessors that way. But in our case, go Lisp string P could be a predicate to check to see if something is a go Lisp string or not. So I'm just going to go ahead and keep it like these two. Compile this, and just to show you, we now have a make go Lisp string. And we can end up leveraging that pretty simply. And what we do is here we're going to have to actually convert the string to the actual the string to the actual Lisp string value. Alright, because in this case, because we're getting our character star, this garbage could be attached to it just because of additional information coming from the runtime. Since we're not actually leveraging that information, that garbage needs to be cleaned up. I'm actually surprised that this piece is working the way it does, just because my understanding is, at least with char stars, in not Lisp, in Go, they would have converted it to the appropriate, char star size, make it into this Go object, pass it over, and then return it. But a lot of the examples that I've been looking at is actually going the other direction. So basically, you would end up leveraging this to pass into a Go function, rather than returning it from a Go function. So we're doing the not the direction that's typically documented, which is calling Go code from C instead of seeing how you interact with Go code in this particular case for Go objects that are not primitive types. All right. And this strategy and this technique should work also for slices, if you want to actually leverage slices too as well. Let's see here. Since I got part of this, I think if I just do this, and say make Go Lisp string, okay, and here I have to use let me see if I could just use foreign string. Oh yeah, I have to do CFFI with foreign string. Oh, you know what? Before I clean this up the way I think it should be done, let me try one more experiment, which is CFFI with foreign string. Var or vars p Lisp string. Let's call it str, and let's see what happens when I do that. Format t, value a, size a, stir n. Okay, let's see what happens here. Undefined variables. Ooh, wait, did I use with foreign string wrong? Hold on. Let us look at the CFFI doc. String. Let me see if I can do that. Let's do. It's not with foreign string. I think I have to convert from foreign. Let's see if I could do convert from foreign value. Hold on. Convert this. No, that's fine. Okay. Here, let's do this. CFFI convert from foreign value p. type string. Let's see what this does. Okay, compiled, but that doesn't tell us anything. Is not a system area pointer. Okay. Got it. This is not a pointer, so that's actually correctly doing what it's supposed to do with foreign slots, which is already doing that for you. Okay. And this is giving you okay. How do I eat this garbage? Because all this stuff is basically probably constant strings that are just getting returned in as part of the allocation. So let me just try this one thing. Def parameter rv print season 3. Okay. Oh, right. This should actually just oh yeah, it's converting it back immediately, isn't it, when you call this? This needs to actually generate the C struct. So let me try one more thing here. So doing a return. I'm curious if I could do this length. Yeah, I think length actually would work here. Length of P. The actual value of the string that's being returned is much larger than the actual size of the string, which is hilarious. Why is that buffer getting returned the way it is? I would have, okay, I guess I could do it this way. This is a little disgusting, but this definitely is pretty safe because, and then I think we could do CFFI foreign free PTR. Alright. Okay, so the first thing is we're going to actually grab this information since we know what type of string it is. It's a little disgusting we're about to show you, but it does work. Given that this is actually consistent. The first part of the actual string is the correct values, but all this looks like what's happening is the buffer size that's happening on the go side is much larger than the actual size that it needs, and has a result, the pointer that's pointing to this char star is getting not just the correct value in overrides, but it's also getting all this other junk garbage that may have been inside the buffer at some point in time. I'll try and create a cleaner way of doing this, but for the time being, this approach will be fairly safe, just because of the fact that we could see that it's a pretty consistent set of values that are being passed over. Since we know the size of the string and we know the size of the pointer, what we could do is we could use subsequence to actually go and leverage. At least I believe we could use subsequence. We could see what happens here. So before we do it, we could just simply say I think it's subseq. Yeah, subseq sequence start optional end is going to be end, and we're going to return this. Oh wait, let's go and compile it. If we go ahead and print it, you can see that now, and it looks like I don't need to actually free it the way I did. So I hosed my my Lisp. So I apologize for that. Let it restart the Lisp. Okay. So okay. Let's go back to what we were doing before, which is this. Okay. Let's load the math library. Let's load this, that, and this. And let's go ahead and print it. And we can see now we have what we want. At least part of it, which is we've built a correct thing that gives us what we matched. Oh shoot, hold on a second. There we go. And let's do this. This. Okay. And let's go ahead and do. Oh, right. Okay. Let's just show you this here. 0, 1, 2, and 3 obviously match winter, spring, summer, fall accordingly, and we are correctly now giving very clean, interesting, correct versions of this. And you can also see that nil is appropriately getting handled too as well. A couple things that are still remaining. One is obviously handling the enum. This also is probably what we saw before, which is we're going to have to write a type translator to translate to this enumeration. One way of doing that is we already kind of have it. As you see here, we do this, and we do CFFI convert to foreign. We say 0, and type is going to be season. Hold on a second. Oh, not convert from foreign. I did it from foreign. I should have said to foreign. Hold on. Apologies. Got to restart my Lisp image again. Okay. Let's do this again. Okay. Value type season. Ah, shoot. Okay. That's not working either. We may need to actually write the conversion routine. Let's see. Okay, so I think I may need to define the CEnum with a wrapper. Give me just 1 second here. I'm just looking at enumerations. Okay, so let's do this one more time. Okay, this, CFFI foreign enum keyword. Type, let's say season, and value 2. Okay, but so if we wanted to use this, we're going to have to do this. We're going to have to probably write another type translator. Def method, CFFI translate to foreign. Okay, value type is going to be season. Okay, and let's do that. And do CFFI foreign enum value type season keyword. Oh, not. Yeah, no, it's keyword value. Let's see that. What is it? Cannot find type or specialized season when executing such class. Oh, shoot. That's right. I have to write an equalizer. I think it's EQL. You have to write an equal specializer to actually do this. Give me a second. Don't remember the syntax. It's been a while since I've done this. This is EQL specializer, I think it was called. And that is yes. I think it's EQL season, I believe. I have to pull up the just 1 second. initializers like this. But we will see what happens. Season is unbound. Hold on. There we go. And let's see what happens if I do that. And go to print season enter. Oh, that's right. Since I did this, I forgot that I did this. I'll do that and do that. Oh, wait. Yeah. Okay. There we go. And so now we have the ability to use our enumerations. So let's review this before we go on to the next part of our discussion. So Go, and again, this here is probably the cleaner thing to do. I just wrote a print function. But to review, to use Go inside your Lisp image, you could definitely build Go as a shared object, and the shared object is going to use the same name mangling scheme as C. We saw that already when we built our Go using the build mode C shared. Number two, we saw that you could leverage the Go API to create fairly complex APIs, as we saw with even strings, because strings tends to be the more complex of the primitive types that it provides. You can expand this obviously to much even larger objects that you define either on the Go side and the C side. And three, for appropriate marshalling between Go and Lisp, you're going to have to create what are called type translators to be able to translate from your foreign type, from the foreign type defined in your language of choice, such as Go in this case, to the Lisp equivalent and vice versa, so that way the appropriate information isn't leaked over. And with Go specifically, as we encountered when we were dealing with the foreign types, you are dealing with objects that are fairly complex and initialized on the foreign boundary, and as a result, you may have to write some of these kinds of quirky workarounds to handle the fact that you are dealing with memory that wasn't actually in control of the Lisp process, but it's able to access the information. So the good news, at least with Go, is at least when it comes to some of its more complex primitive types like strings, it gives you all the information that you need to be able to write these workarounds in a fairly safe manner. You don't have to necessarily go out of your way to actually show the garbage that as a result of them potentially reusing the same pointer in memory and to actually get information. I'm going to pause here for just a minute because this was a little bit involved, just to see if there are any questions from folks. I see one comment from the Jitsi. Yes, I do type pretty fast. My apologies. Just a quick show of hands. I hope my presentation font size is decent enough for those out there in both YouTube land as well as the Jitsi. Just because I actually went out of my way last week to spend some time correcting like some global settings, and I created some macros for myself inside Emacs Lisp to be able to make sure that all buffers are at the same font size. But if it needs to be larger, by all means, let me know. I do know some folks and I appreciate hearing this in the YouTube comments. They actually were complaining about the font size and some of the buffers last week because they were trying to watch my videos on a TV screen. So I tried to make sure that the font size is as big so you could watch it on a TV screen. So I wanted to make sure that everything is good. It looks like I'm getting some good responses there. All right. Okay, so here's a question. Is FFI widely used in Lisp versus other languages? Yes and no. There is a lot of situations in Common Lisp especially where the foreign function interface did and was leveraged to actually get a particular third-party library into Lisp very quickly. Some examples of this actually include CL0MQ, which is the ZMQ bindings for the Common Lisp bindings for 0MQ, a fairly popular message passing library, message queue library. There is equivalents for Rabbit, as well as foreign function interfaces defined for pretty much any database that you've leveraged, because behind the scenes a lot of them tend to have fairly complex but fairly mature and robust C libraries that they use to be able to have very efficient interaction with their databases. I'm not going to list all of them here just for sake of time, but this is kind of the standard. You could say almost it's a standards of practice. Like a lot of languages, just so that they don't have to reinvent the wheel, or in many cases so that they can actually have a quick prototype while they're actually designing the more robust version, have a tendency of writing these foreign function interfaces and interacting with C and other foreign libraries, while at the same time probably trying to create a native specific version of the particular library that they're leveraging. Okay, so a follow-up to this is talking about could REST/XML be an alternative? Writing REST APIs, I would say, is almost a separate issue than dealing with the foreign function interface, because a foreign function interface is usually assuming that the Lisp application is running in process. It's not dealing with more of a distributed context. So you could think of a Lisp wrapper or a Lisp API above a REST client or to an actual API as being almost the equivalent of what we're trying to accomplish here with the foreign function interface. Because if you recall, a lot of times when you're writing stuff to a REST API, you almost always have to deal with serialization, deserialization of native objects and mapping them appropriately to some JSON representation. And sometimes that can work, sometimes it may not, especially if you're dealing with binary formats. So you have to account for those when you're designing your higher level APIs and communicating across the wire. In much the same way here, when you're dealing with foreign functions and foreign function interfaces across different alien languages, for lack of a better term, from the language that you're leveraging, whether it be Common Lisp, Python, or whatever, you almost always want to make sure that the wrapper and the boundary is well defined between you and that foreign world. So in those cases, this technique of creating a Lispier or a Pythonic or a Ruby or a Java style API above your foreign language would be useful. In Common Lisp's case, because it was one of the first, I think, to actually adopt this scheme, some of it, its techniques was just kind of scooped up by other languages. I'm just going to say that of the languages that I've personally used, Common Lisp is amongst the top 5 for having a fairly mature C foreign function interface compared to the other languages, but that's just from my experience. your mileage may vary. All right. Let me, in the time remaining, quickly discuss just the other issue that I want to hopefully discuss, and then I may jump into some other material if other folks are interested. And feel free to drop off if you're unable to stay on longer. But the second thing that I want to discuss is mainly dealing with calling Lisp streams. Calling Lisp code from C. So I want to remind everyone kind of where we were at on that front from last week. Okay, we wrote a piece of code, which I have since moved over to this directory called mymath.lisp, that defined an alien callable. Now, a review, alien callable is basically a SBCL specific API that was defined to allow one to actually write exported symbols in, again, it's a running theme here, a C style shared object that can then be leveraged by other libraries and other native languages if they, adhere to the C API. Okay, and we used this define alien callable and created a Lisp core image by using save Lisp and die. And many of you probably recall this, but the thing that we encountered that I mentioned last week is you can't just simply call and define this in your slime session, mainly because of the fact that save Lisp and die does not like multiple threads of execution being available at the time that the core is actually being dumped. And more specifically, when you're trying to call it with a callable export, it doesn't like that. If you're creating an executable, so if you did save Lisp and die with, I believe it's top level is true, like this, with the core name, I have to make sure that the core name is actually available. Software projects. Okay. Projects. MyMath. Okay. And we do mymath.core here. This will allow you, the top level, to actually go ahead and dump everything with multiple threads. But these two are mutually exclusive. You can only have one or the other. All right. You cannot actually have both being available. So when callable exports is called, because we're actually running stuff in the background when we're dealing with Sylvester or Slime, things like Slink, the Slime thread for interaction, the Swank server to actually communicate between Emacs and stuff. This script, if you actually end up loading it into your session, will end up throwing an error saying that you have like 5 or 6 threads being available. And we saw this last week when you tried to load this file into our session, and we saw this being thrown up. So one thing that I encountered I ended up doing is I ended up going into our shell and being able to run SBCL to dump the Lisp core. But I found out from from doing some digging last week that there are some additional steps that you also need to do in order to compile the core for this file and this simple API, and you can adopt it to much larger APIs. And that is the core image needs to match the version of the shared object that you are trying to load it from. What I mean by that is you compile SBCL has a DLL. You want to load it into a C library. The version of SBCL that you compiled has a shared library. That version of SBCL is the one that you need to use to create core files. This is because different versions of SBCL may or may have breaking compatibility changes, especially when it comes to APIs. And I'm not talking necessarily about core vanilla common Lisp. This stuff that you're seeing here is not core vanilla common Lisp. This is SBCL specific, and as I mentioned last week, although it's SBCL specific in this particular case, it is my sincere hopes that other open source Lisps provide a way to being able to define alien callables, and let me know if there are other ways. I do know that commercial Lisps provide some way of doing this, and they're very well documented, but I shall defer you to those products documentation for more information. I believe I do not have any ability to take one of their express versions and be able to experiment with that with this particular use case. I think that's something you have to actually purchase as part of their licensing scheme. So since I've already built SBCL, I thought I would show you very quickly how to create the core file like this, and then move forward with actually some of the other examples that I've encountered with this. But so the one thing that I'm going to have to do is I'm going to have to use full paths here. And with SBCL, there is a function, a shell script called run SBCL. .sh, and this is what you can use on the command line as part of, instead of trying to put this on the path and all this kind of stuff and deal with multiple lists being available on your system. You can just do the absolute path like this and then pass in a script file and then pass in the script that you want to compile, and it'll go ahead and dump the core for you. So here we now have a core dump, as you can see here. And you can actually run this by doing, again, run SBCL sh core mymath.core -- no inform. But you'll immediately see and encounter the next issue that we were seeing last week, which is this has an undefined alien variable. Okay. Last week we actually saw a seg fault, but the seg fault was actually because we were trying to take a core from a version, although they technically are matching, from a version of SBCL that does not match exactly to the version that I was actually trying to load it in from, and as a result, it ends up throwing up an error. And I encountered this undefined alien variable to actually load it up, but to show you that this actually kind of all works the way we expect it to, I've already created let's see, last week, this kind of core piece of features that essentially, currently, we're not actually even creating anything that's being passed to and from it. All this was doing is kind of what we encountered last week, tried to initialize the Lisp. And initialize Lisp is actually what it's actually what run SBCL.sh uses to start up SBCL. It's actually the core function, it's the entry point actually to the REPL. And the no inform, what it does is it actually prevents you from actually seeing the garbage initialization, well, not garbage initialization, you'll see a lot of debugging information about the SBCL, the version and stuff, and you can actually see this when we run this like that with no arguments, and that is, there's a lot of this preamble stuff about this is SBCL 2.42. It talks about it being common Lisp, it talks about where you can find information, and it gives you your basic licensing guarantees before actually running the actual core file, which ends up resulting in this particular error. So you want to run this with no inform both on the command line as well as on from within the shared object version. We already saw how this gets compiled. I'm not touching on new territory here. For folks who are unaware, this is using just kind of your standard, GCC code, and you have to specify in the -L library path. And I don't think I have to mention this to most of the Lispers on this channel. The directory where the SBCL shared object is. Of course, if you're using SBCL-Librarian, it tends to copy that over into your directory. I'm just ignoring that for a moment for the sake of just kind of leading us into this. And this can then be used to compile this mymath.c and load it, and you'll see that it gets compiled into this mymath executable that if we try to run, and again, in order for us to run it, we have to actually specify the location again, because I didn't copy everything locally for the time being. I'm not saying that this is the correct, the long-term way of doing this. It's just to kind of show you kind of step by step where things are coming from. So one time, and mymath.org, you can see here that we end up getting the same variable. This is kind of where we left off last week. So the reason why this is happening is actually because of the fact that in SBCL, when you're dealing with external functions that are getting generated and you're dumping stuff into the core, it's supposed to actually generate a bunch of these foreign function calls, one of which is it's complaining about here, which is a call into Lisp, okay, the foreign function. And unfortunately, this is part of the generation. This is not actually part of the SBCL initialization, okay? And what I've been digging into this is I've been wondering how SBCL-Librarian does this, just because SBCL-Librarian, because again, the goal is to ultimately, if you're going to end up using Python and even the stuff that I was kind of showing with Go bindings, we'd like to have kind of a single thing. And I think SBCL-Librarian, the folks who wrote that library actually did a good job in actually encountering this even in their examples. But I kind of wanted to know why this particular piece isn't working for me as is, and it was working for them. If you end up compiling their library, their examples, all right. We can certainly get to the end goal of compiling our code the way they want to, but that would require us to actually write out a Lisp file that defines our API more formally, generate the bindings, and then there's a lot of macro magic that ends up happening behind the scenes where they take the API that you provided, the type information that you provided, and generate the appropriate headers needed to actually go and load and use those libraries in other native languages, as well as building the actual so file that holds that API intact. So I didn't want to actually go into that world without understanding kind of what it is that they're doing. So that way, if we encounter particular issues, since again that library is a fairly new library that's just getting more of its bearings, although there's more folks that are now picking it up, it's going to certainly have bugs, and it's better for us to actually understand where it's coming from before trying to dig into it and then complain that stuff is happening behind the scenes. So that's kind of the approach that I'm taking. So I'm digging into this particular error because this is kind of interesting that this call into Lisp is actually not getting defined from foreign function, because as you saw in our my math.lisp example, it is actually, this here is building out alien callables, alright? So the first thing we'd want to probably see is, well, what does this hash table hold, this global alien callables hash table, and why is it that it's not actually keeping some of these other foreign functions in there? So this is the kind of stuff that you can actually end up debugging yourself in from your Sylvester session until you are prepared to actually do a save Lisp and die, and then you have to go into your E shell to do the save Lisp and die. So this is the first thing that I thought it would be useful for us to kind of play around with in the time remaining, kind of see where it's coming from. So let's see what this hash table holds, shall we? Alien callables. Okay, so this is holding just our add function. Type function sign 32. Let's see what this is. Okay, sign 32, return sign 32. Okay. We have a rehash threshold. Okay, hold on. Go back here. Contains only one thing here. So there's nothing else actually in here. But what other stuff is being held here when I'm dumping alien callbacks? Maybe it's this stuff? Let's see. Nope, this is all talking about okay. So it looks like our add's actually getting added into the hash table as we expect it to, but I'm wondering if there is something else I need to provide to save Lisp and die in order for me to actually generate. Unfortunately, right, that section on defining alien callable in the SBCL user manual is a bit lacking in telling you like where this information is getting stored and how it's getting dumped out. So I may have to reach out to the SBCL community to see if there is something else that I need to pass in as an argument to actually get those foreign functions dumped into the same hash table. Because it looks like there is something here that I'm missing, at least based on what I'm seeing in terms of what's available and what's not available. Because it's clear that you can, if you do this, get hash add callables. Okay, and get hash table, right? You'll end up retrieving the actual function that contains 3 arguments, well, 2 arguments and returns an assigned integer. It's just for whatever reason it's not actually adding those 2 other dumps that we kind of wanted here, specifically call into Lisp and post signal tramp. trampoline, which should be available as part of these two other, I think it's called callback trampolines. Yeah. So I'm not entirely sure why say Lisp and Die is pruning them out. It more than likely is probably a missing argument in say Lisp and Die that I just haven't encountered yet. And if we look at this here, there are a lot of options that are being used here. Whether it's say runtime options, root structures, executables, and things like this. I don't know what it is. I would have to do some trial and error, to be quite honest with you, to encounter that. But I went already a little over than what I kind of expected. So next week we'll probably close this off, and then I can finally show you SBCL-Librarian for Python and C, and we could see how we can extend it for the Go example and maybe even some Rust, depending upon time being. Are there any final questions from folks watching? Okay, I wish you all a great weekend. For those of you who are in the Atlanta area, looks like we have a pretty decent day outside. So enjoy your Saturdays. I'm hoping you guys all have sunny days in your parts of the world. And I'll see you guys next week.